Welcome back to KSET previous year question and solution classes. Today I will discuss KSET 2020 paper. Okay. The first question is from vector calculus. So the question is like this. Identify the vector that is perpendicular to both of these two vectors from the following. So these are the following vectors they are given. So we have to calculate the vector in these four options. Which vector is perpendicular to both these two vectors. So that we are going to find. So to calculate, we know that dot product of any two vector is equal to 0 if A is perpendicular to B. Vector A is perpendicular to B, and which is equal to 1 if suppose vector A is parallel to B. Now, if we take a dot product of any vectors with this and this, with this and this, so we have to verify each one and we have to calculate in which vector the two vectors gives 0. So, if A dot B is equal to 0, then it indicates that A is perpendicular to B. Okay. So, let's see. If suppose this is our A vector, if this is A vector and this is B vector, okay, or this is A1 vector and this is A2 vector, let us take A1 vector with this B vector. So I dot I is 1 and plus J dot J is 1, 2 3s are 6 plus minus 3 2s are 6. So minus 6 plus 6 cancel, answer is 1. So this is not a answer. Next, option B. 1 I into I, 1, 2 1s are 2, plus 2 3s are 6, minus into plus, minus 3 1s are 3. So from this option, 6 plus 2, 8, okay, 8 minus 3 is 5. And this is also not a correct answer. Next, so this is minus plus I into I1 plus into minus minus 2 3s are 6 plus 6 and minus 3 3 2s are 6 minus 6. So which I calculated this one, right? I, okay, here it is 5 is there. So I into I 1 and this is minus 1 because minus sign is there. 5 2s are 10 and minus 3 2s are 6, sorry, 3 3s are 9, 3 3s are 9. Therefore minus 9 minus 1 plus 10. So minus 10 plus 10 which is equal to 0. Okay, option C is satisfied. Let's go to the A2 vector. So minus into minus plus 1, 1 into 5 plus 5 and 3 2s are 6. So minus 6 plus 1. So therefore plus 1 plus 5, 6. 6 minus 6 is equal to 0. So therefore this C option is perpendicular to both this vector and this vector. So option C is correct. Okay. Second question is also from vectors, differential of vectors or vector calculus, and this is a direct question. We can easily calculate this one. So this is the phi that is given and A that is given. We have to calculate vector A dot del phi. We know that phi is equal to 2x square y. Del phi, which is equal to del means I into dou by dou x plus j into dou by dou y plus k into dou by dou z. And phi is 2x square y. Then which is equal to I into dou by dou x. So 4x y I cap plus j. So 2x square j cap plus k in cap into dou by dou z. There is no z term, so it is 0. And del phi we have to calculate at 1 comma 1. That means x is equal to 1, y is equal to 1. So which is equal to so 4x, x is 1, y is 1, 4 I cap plus x is equal to 1, so 2 j cap. So this is del phi at 1 comma 1. So now we have to calculate a dot del phi. Okay, so what is a cap? Vector A is 2y I cap minus x square y j cap, and del phi is 4 I cap plus 2 j cap, and let us take a dot product of these two. Okay, so then dot product of these two gives I into I1, and at y is equal to 1 and x is equal to 1, so it is 2, 4 2s are 8 minus plus into minus minus x is equal to 1, y is equal to 1, so this is 1, 2 1s are 2, so 6. Option C is correct because this is 2 I cap minus j cap at x is equal to 1 and y is equal to 1. So this question is based on the properties of Dirac delta function. So this is the question given. In these 4 options, which one is the correct? We have to calculate. So the question is in the form of minus infinity to plus infinity, d by dx of dou of x can be written as dou prime of x and e power ikx dx. So this is just like integration of minus infinity to plus infinity f of x dou prime of x dx, okay, which is equal to minus 1 power 1 because 1 prime is there. So integration minus infinity to plus infinity, which is f dash of x into dou of x into dx. Therefore integration minus infinity to plus infinity, and here our f of x is e power ikx, and therefore minus 1 power 1 into f dash of x. So differentiation of this e power ikx, differentiation of e power ikx is ik into e power ikx, okay. Next into dou of x into dx, and we know that in the last video also I explained this, integration a to b f of x dou of x minus c dx is equal to f of c if suppose c lies between a and b. Here is there is no term here, means it is included here, it is 0, and definitely 0 is lies between minus infinity to plus infinity. Therefore the answer is I am going to write here, okay, minus 1 into, and this is f of a, let us take this constant ik into f of a. F of a means this is f of a, means here in place of x we have to substitute f of c. So here c is 0, so therefore e power 0. Answer is minus 1 into ik minus ik, okay. So minus ik is option D. This is the correct answer. So this is the question number 4, which based on differential equation. So this is the given differential equation, homogeneous second order differential equation. you have to calculate you have to get the solution for this differential equation. Okay, so this can be written as in the form of d square plus 3d plus 2 of y is equal to 0, and this is also written as in factorized method m square plus 3m plus 2 is equal to 0. We know that how to factorize, like it's a quadratic equation. It looks like a quadratic equation, ax square plus bx plus c. By factorized method, let us take 2 into the coefficient of m square is 1, so 2. If we multiply 2 digits, it has to be 2. If we add these 2 digits, it has to be 3. Okay, let us take if suppose this is 2m square, 2 into m square, 2m square, then 2m plus into 1m, m into m square, 2 ones are 2, 2 plus 1 3, 3m. So therefore we can write this as m square plus 2m plus m plus 2 is equal to 0. Okay, next, so therefore let us take m is a common, so m plus, if m comes out it is 2 plus not possible to take as m, let us take 1, so then it is m plus 2. Therefore the solution is m plus 2 and m plus 1. Therefore m is equal to plus 2 and plus 1. The solutions are real and distinct. Therefore y is equal to e power 2x and y is equal to e power x. So any option, y is equal to e power 2x and e power, so this is m plus 2 and m plus 1 means m is equal to minus 2 and minus 1. So therefore e power minus 2x and x. Any option? Yes, option number A is correct. E power minus 2x and e power minus x. Easy question. So question number 5, the number of independent components of a real antisymmetric tensor of rank 2 is 4 dimensional. So here the formula to calculate the antisymmetric tensor, number of independent components of antisymmetric tensors is n into n minus 1 by 2. And it's a 4 dimension, so 4 into 4 minus 1 by 2, so 4 into 3 by 2, so 2 ones are 2 threes are 2 twos are, so 3 twos are 6. So there are 6 independent components of real antisymmetric tensors. Okay, it's very easy. If they ask like this, independent components of symmetric tensor and antisymmetric tensor or orthogonal matrix or special unitary matrix. Okay, so this type of questions is very important and also very easy. So this is the question based on complex analysis. Okay, so here v is given, we have to calculate u. v of x comma y is given and we have to calculate u of x comma y. So u of x comma y is equal to dou u by dou x into dx plus dou u by dou y into dy. which is equal to dou u by dou x. So here there is no u, so that's why we have to convert u into v. So how to convert? We know the relation dou u by dou x is equal to dou v by dou y, and dou u by dou x is equal to minus of dou u by dou y is equal to minus of dou v by dou x. So dou u by dou x is dou v by dou y into dx plus dou u by dou y is minus of dou v by dou x into dy. Integrate. Okay. So next, so after integrating, here we can use the trick, that is keep y constant. Okay, y is constant and no x term. Okay, so therefore which is equal to dou v by dou y. So what is dou v by dou y? See, dou v by dou y, which is equal to, with respect to y, differentiate 2x, and dou v by dou x, which is equal to 2y. Okay, and plus integration constant, some constant. So therefore, see, I am going to rub this part. So therefore, integration of dou v by dou y is 2x into dx plus minus integration of dou v by dou x, so that is 2y into dy plus constant, integration constant. Here we can apply a trick, that is keeping y constant and eliminate x. Eliminate x means x coefficient is 0. Put in place of x 0. So which is equal to integration of y is constant. So here there is no y term. Okay. Therefore integration of 2x is x square by 2 and 2 cancel, minus integration of y is y square by 2. Actually here on this 2 and these 2's are cancelled. Okay, so answer is x square minus y square plus constant. So is there any option? X square minus y square is there, but instead of constant again xy function is there, so this is not a correct answer. Here x square minus y square is there, but one more term y is added, so this is not a answer. Here x square minus y square is there plus constant. Okay, this is the correct answer, because here also some extra terms is there in terms of x, it has to be constant. Okay, so option number C is correct. So the value of the integral dz by z, where C is a unit circle with origin as its center and the integration is done in a clockwise path. So here we have to calculate the integral in clockwise direction. Okay, so let us take, we know that for a circle z is equal to r e power I theta, and it's a unit circle, that means r is equal to 1. So z is equal to e power I theta. Next, therefore dz is equal to I theta into e power I into e power I theta. Okay, therefore integration dz, in place of dz let us take I into e power I theta, and so that is dz divided by z is e power I theta into d theta. Okay, so z is e power I theta and dz is e power I theta into I. Limit varies from 0 to 2 pi. For a circle, limit always varies from 0 to 2 pi, and for if it is counter is in anti-clockwise direction, it is positive. If the counter is like this in an anti-clockwise direction, it is positive. If the counter is in clockwise direction like this, it is negative. Okay, so therefore which is equal to d e power I theta cancel, integration 0 to 2 pi d theta, and which is equal to I into d theta is theta 0 to 2 pi, and which is equal to 2 pi I. Because of clockwise direction, let us take this is negative, so minus 2 pi I. Option B is correct. And this is the question number 8. The number of independent parameters of the group O3, or we can also call it a special orthogonal matrix of 3 cross 3 and a special unitary matrix of 2 cross 2 are respectively. So to calculate number of independent parameters, and the number of independent parameters for O3 or SO of 3 is n into n minus 1 by 2, and the number of independent parameters for SU of 2 is S square minus 1. So this is n is order 3 into 3 minus 1 by 2, so 3 by 2 into 3 minus 1 is 2, so 2 cancel, answer is 3, and which is equal to here S square, S is 2, order is 2 2s are 4 minus 1 is 3, so 3 and 3, option A is correct. So this is the question based on eigenvalues and eigenvectors of the matrices. So this is the given matrix A, and we have to calculate eigenvalues of e power A matrix, exponential power of A. So one of the eigenvalue of this e power A matrix, A is this one, is e power alpha. Next we have to calculate the product of other two eigenvalues. See, first let us calculate eigenvalues of this matrix A. So that means if we multiply the eigenvalues, it gives the determinant. If we add the eigenvalues, it gives the trace. For this matrix, determinant is alpha into 0 minus into minus plus I square alpha square. So which is equal to alpha into I square is minus alpha square is alpha square into alpha cube. So determinant is minus alpha cube. Trace is alpha. Okay. So therefore, if we add, which gives trace. If we multiply, which gives minus alpha cube. So that's why let us take minus alpha cube is nothing but minus alpha plus alpha, okay, minus alpha plus alpha square, because minus into plus minus alpha square into alpha cube. So therefore if we add all these, plus alpha minus alpha. So plus alpha and plus alpha minus alpha. If we add all these, so plus alpha minus alpha cancel, alpha is the trace, and if you multiply all these plus alpha minus alpha, so it is minus alpha cube. So therefore other two eigenvalues is plus alpha and minus alpha, and we know that e power product of e power eigenvalues, exponential power of eigenvalues is equal to e power sum of trace, so which is equal to e power eigenvalues are alpha and other two eigenvalues are e power minus alpha and e power plus alpha. E power plus alpha they are given, and e power minus alpha and e power plus alpha is e power 0, and e power 0 is 1. So answer is 1. So this is the question based on probability. 3 fair coins are tossed together. Find the probability of getting one head and two tails. One head and two tails. So for a coin problems, basis is equal to head and tail. Only two possibilities. And number of microstates is 2 power n. So here there are 3 coins, 3 pairs of coins is there, so which is 2 power 3, that means 8. So 8 possible types of arrangement we can made, so we can make from this coin experiment. What are those? Head, head, head. All the 3 coins may be head, 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 and otherwise 2 head and 1 tail, otherwise 1 head and 2 tails, okay, otherwise tails, tail, otherwise 2 head, tail. So 1, 2, 3, 4. Other one is maybe head, tail, head, or tail, head, or so first one is tail, another 2 is head, or so head, tail is over, tail, head is over. Next 1, 2, 3, 4, 5, 6, and other 2 is tail, head, okay, so tail, head, and tail, head. 1, 2, 3, 4, 5, 6, 7, and the next one is tail, so tail, head, tail. In the center here it is head, another 2 is tail. So in the question they are given 1 head and 2 tails. So 1 head and 2 tails, what are those? How many favors are there? 1 head, 2 tails, and 1 head, 2 tails, and 1 head, 2 tails. Next, is there any other options? No. So therefore probability P is equal to number of favors divided by total number. So which is equal to how many possible of 2 heads and 2 tails and 1 head is 1, 2 and 3. So therefore 3 by 8. So answer is 3 by 8. So given the matrix A is equal to 1 by 3, 1, 1, 1, 1, 1, 1. So what is the value of the determinant of e power A? So the eigenvalue of this identity matrix, if this is the identity matrix, the eigenvalue of the identity matrix, sorry, this is not identity matrix, it's an identical matrix. So if the matrix is like this, A, or A, okay, or A, B, and again A, okay, or it is like this 1, 1, 1, 1, 1, 1, 1, 1, 1, or 1, 1, 1, 2, 2, 2, and again 1, 1, 1. So these are all identical matrix. For an identical matrix, eigenvalues are 0, 0, trace. 0, 0, trace. So that is 0, 0, trace is 1 plus 1 plus 1, 3. And again, you know, 1 by 3 is there. So 1. Okay. So for this matrix, 0, 0, trace is 2 plus 1 plus 1, 4. But here one more 1 by 3 is there. So that 1 by 3 we have to divide. So 3 by 3 is 1. So the eigenvalues for this matrix is 0, 0, 1. Okay. Next. Determinant of e power A is equal to product of eigenvalues. So which is equal to, what are the eigenvalues? So we know that e power 0, e power 0 and e power 1. We have to add all the eigenvalues, and that eigenvalues is equal to determinant of e power A. So therefore, so e power 0 plus 0 plus 1. So answer is e power 1. Product of eigenvalues or sum of eigenvalues. Exponential power of sum of eigenvalues or product of eigenvalues. So answer E. Option number B is correct. Okay.